slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some honestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
Extremely crucial, as it creates the lift and controls the direction of the flight. The leading edge of the aircraft is designed to be sharp to ensure that the air flows smoothly over it, while the trailing edge is designed to be curved to ensure that the air flows off the fuselage in a smooth and efficient manner. When comparing this with a normal aircraft with fixed wings, they generate lift through the shape of the wings. The wings are designed to have a curved upper surface and a flatter lower surface. The air flowing over the wings creates a high pressure area on the bottom and a low pressure area on top, which creates lift. It's not entirely different than the lifting body aircraft, it just uses its wings instead of its fuselage. In 1961, NASA's AIM Research Center, led by Dr. Alfred J. Eggers, began designing a lightweight, unpowered test vehicle to investigate the concept of the lifting body aircraft. But they ran into some problems almost immediately. One challenge was the aircraft's lightweight construction. Since the M2F1 would have limited lift available, it was designed to be as lightweight as possible, which made it more prone to turbulence and more difficult to control. The engineers had to work on finding the right balance between weight and strength to ensure the aircraft's structural integrity. Dr. Eggers and his team decided to use wood and fiberglass as the primary construction materials for the aircraft in order to keep its weight low, although it had some steel and aluminum components as well. Finally, on August 1, 1961, NASA's Flight Research Center at Edwards, California was officially tasked with building the now completed M2F1 prototype. The M2F1's first flight tests were conducted at Rogers Dry Lake, utilizing a 1963 Pontiac Bonneville convertible as a tow vehicle. On April 5, 1963, test pilot Milt Thompson successfully lifted the M2F1's nose off the ground for the first time while being towed at a speed of about 86 miles per hour. However, during the flight, the aircraft encountered unwanted bouncing between the main landing gear wheels. Additionally, it was found that the tow car was not powerful enough to lift the M2F1 entirely off the ground. To overcome this issue, NASA's Flight Research Center arranged to have the car modified by engineer Bill Straub, which tuned the engine for increased power, added a roll bar, and turned the front passenger seat to face the aft so the passenger could observe the aircraft. With these new modifications, the tow tests were successful, and the speed on the tow was increased to about 110 miles per hour, allowing Thompson to climb to about 20 feet and glide for 20 seconds after releasing the tow line. These initial tests provided valuable flight data on the M2F1's performance, allowing NASA to proceed with flights behind a US Navy C-47 tow plane at much higher altitudes. And into the air she went. The C-47 took the M2F1 to an altitude of about 12,000 feet, from which point it free flew all the way back to the Rogers Dray Lake runway where it began. The typical glide flights lasted for about 2 minutes and reached speeds of about 110 to 120 miles per hour. Once it reached about 1,000 feet above the ground, the nose would be lowered in order to increase speed to about 150 miles per hour, and would move to about a 20-degree dive, giving it a rather smooth landing. The M2F1 was flown until August 16, 1966, and it proved the lifting body concept as viable. This paved the way for subsequent designs of wingless aircraft, such as the heavyweight designs of the Northrop M2F2 and the Northrop HL-10, both built by the Northrop Corporation. The M2F2 was constructed primarily of metal rather than wood and fiberglass, as it was with the M2F1. This improved the aircraft's structural integrity and strength, allowing it to withstand higher speeds and altitudes. It had some other improvements as well, but one of its test models crashed in May 10, 1967, so let's focus on the much more successful model, the HL-10. During the lifting body research program, the HL-10 was flown about 37 times, logging the highest altitude and fastest speed of any lifting body aircraft. On February 18, 1970, Air Force test pilot Peter Hogue flew the HL-10 at a speed of about Mach 1.86, which is about 1,200 miles per hour. 9 days later, NASA pilot William Dana flew the aircraft to a height of about 90,000 feet, setting a new record for the highest altitude reached in the program. According to R. Dale Reed, the project engineer for the HL-10, the aircraft was originally intended to be used for spaceflight in the 1970s.
We flight test people felt that if we were to fly one of these and demonstrate that they can fly, then they would be the lifting body would be considered for future designs for future spacecraft.
With the cancellation of the Apollo Moon project, however, Reed realized that there would be a surplus of Apollo hardware available, including flight-rated command service modules and Saturn V rockets. His proposal was to modify the HL-10 with an ablative heat shield, reaction controls, and other subsystems necessary for crewed spaceflight. The modified vehicle would then be launched into space on a Saturn V launch vehicle with an Apollo control module. The program was planned to include 2 flights. In the first, the lifting body pilot would return to the Apollo and send the HL-10 back to Earth uncrewed. If this flight was successful, the second launch would involve a pilot landing from space all the way down to the Edwards Air Force Base. However, the Flight Research Center director overruled this proposal, and it never came to fruition. By 1975, the lifting body research program had flown their last flights, and were largely abandoned for more conventional aircraft. However, the legacy of wingless aircraft lives on today in the development of new aircraft technologies, including unmanned aerial vehicles and hypersonic aircraft. The lifting body aircraft pushed the boundaries of what was thought to be possible, and paved the way for a new era of not only aviation, but spaceflight, with the Falcon 9 rockets themselves even borrowing some concepts for their design. So I guess Elon should send his thanks. Hey everyone, thanks for watching, hope you enjoyed that video. We have another really cool video about some of the most bizarre and esoteric aircraft designs ever created. Some of these planes likely should never have flown, but some crazy engineers got them to work. I think you'll really like it. You can click on that image there to check out the video. Don't forget to like and subscribe if you enjoyed this video, and thanks for watching.